very happy that I see you on my session. My name is Piotr Stawirej, and today I will tell you about Java Platform Module System, basically from theory to practical application. A bit slides about me. I work for TomTom for over 11 years, so it's not very common for the developer to stay as long for one company when we are delivering various navigation services, creating backend system for the autonomous driving cars, creating three-dimensional map of the world, and enable the services for the future smart cities. And recently also, I became proudly Bottega IT Minds part, and when we are giving the trainings with my colleagues on the various topics for the IT industry. And at the beginning, we will start talking about evolution. So when life pop up on Earth, since day one, basically, each organism has to adapt to the new environment. And you know, like life happened for the millennia, there were some unexpected environmental changes like meteor strike or dramatic climate change. And if you didn't adapt fast enough, you just simply perish. And we observed this for the millennia. And why I am talking about this? Because this is very similar to our IT industry when new languages, new frameworks, new solutions just pop up, and from time to time, we see which of them were filtered out by our natural filter in IT industry, which were relevant to the business, and which were not. And one of this concept was Java Platform Module System. And this is not the new concept. As you see here, there were already some tries to introduce this in the 2005. And yeah, it was called Java Module System. But in the same time, the OSGI 4.1 pop up. And also through the last years, there was tries to improve modularity support in 2006. In Java 7, there was no Jigsaw, and also no Jigsaw in Java 8. But still, the Java Platform Module System was introduced as some proof of concept. And finally, in the 2017, when Java was released, Java 9 was released, the JPMS was introduced. And why it was introduced in the first place? So the people would like to modularize the JDK itself. They would like to create some solutions for the micro devices, basically when the size matters. So we would like to have a bit small part of the Java on these devices to save space. They would like to improve security, maintainability, performance, and they also would like to hide some platform internals. So maybe you notice already, like, for example, Sun, Misk, they are already hidden. And they would like to create some reliable application composition. So basically, this was the ideas and how everything was done. One stop here, because I would like to talk about the modularity concept itself. So what do you think? What is the problem in some context with code like this? So issue is with the public, in fact. And here I've encountered the situation in my life as a developer when people had, like, by default, creating the new classes as public. And so we built some system, the big one, and we noticed at some point that, hey, we're creating everything as public, and some of this implementation, maybe they shouldn't be created as public, and maybe the customers shouldn't use them and not be even aware about this. So we hide a lot of these public classes as private, and then what happened? Then the business came and said, you broke something. But what? Now you released the new version of software, and our software stopped working. What did you do? And we spotted that they used our internal implementations without our knowledge. So lesson from this is that if you expose something to your customer, to your client, they will use it, even if you don't want them to use that. So be aware about this. So here we have the modularity concept, which is not a new concept. because we are going to implement, we were implementing this in various languages through the years. And the idea is to hide our internals in the module. And here, the modules talk by the service contract. In Java, what is the service contract? The interface. So we have this pact between the modules, and they talk, and this implementation of this interface shouldn't change, or should change very rarely. So the module can talk to each other, and here we can do a refactor, try the new implementation, switch the modules, basically, and this is the idea of the whole modularity. And just now we are going to dive into JPMS itself. So let's start from the example. So the theory says that we can have the project, and here we have the API, Earth, Elon, Mars. This is the module created by using the JPMS itself. Let's just dive in the certain sections. So Elon in this example is like our main. So this will be our main module, which will just trigger everything and runs everything. And we see here, like in JPMS, they introduce new keywords. So we have like module. And here, I would like to stay for a moment about the name. We should use reverse DNS, so reverse domain name system names, because modules are recognized by names, and the name has to be unique. And this is very important. I would like you to remember that. I will show later what kind of problems we will have if we will not have the unique name. So here on this example, we have just module.elon, but in the real system, we would like to have like com.company. Some functionality some module name. So basically something like in the Maven modules group. And here this module, Elon, requires API, Earth, and Mars. And what is the implementation of this class Elon? So basically, we are creating here new class Mars. Here is already examples in Java 10. And when we are displaying greetings from Mars.name, it will just display greetings from Mars. So we have in Mars module the package planet.mars and module.info. As you know, the module.info is not a valid name for the Java. Probably you know that because we had also in the past package minus info. So this minus is not a valid character in the name, but it was deliberately introduced here to distinguish that, hey, this class just displays and show us that this is the description of the module itself. And the good practice is like name of your module, which is here, defined in this module minus info.java file, will be the same as the package. So this is the good practice, but not necessary. And here, in this module, we see that this module requires API module, which basically is the simple interface with the one method for the purpose of this exercise with name, and it exports this package. And here we have the implementation of the Mars class, so we see that it implements the planet module and just simply implements the name method. So everything should be simple enough. But let's visualize this. Oh, one more thing. We are not allowed to use the wildcards, so when we are requiring modules, I just cannot type here as star, so module.star will not work. Also, I'm unable to export the empty package. But let's take a look about the implementation from the visual perspective. So here we have our API. Here we have our Earth and Mars modules, which are using the API module. And here are our main module Elon, which requires all those three. Do you see an issue with this picture right now? So, a lot of coupling. Thanks God we don't have the cyclic dependencies here. But basically everything is using everything. Elon has to be aware about the API, Earth, Mars also, and also Elon is using Earth and Mars modules. So we don't want to have that. Is this any possibility to fix this in JPMS? Yes, there is some concept like implied readability, when in fact you can have like requires transitive. Requires transitive states that, hey, I have this API, and if I will use the ERV module, because now I'm working on the ERV module and I'm export my package from the ERV module, so if someone is going to use ERV module, just tell him that I'm using also API, and this module also should be aware about this API. So we just get rid of one explicit dependency. Yes?
What if both of those modules export transitively the API in different versions?
I will talk about this later. So for the questions, let's just save them for the finish of the talk. So we have this transitiveness, but it still have a lot of coupling. So how we can improve that? And also, what about if you would like to have a module like Jeff, and Jeff would also like to send a greetings from Mars, but we would like to forbid it. So we have something like qualified exports. So I am able now to export the certain package to the certain module. But what is the problem with that? It seems that we are violating a bit the open-close principle, because we are introduced, in fact, a coupling to the specific implementation. Imagine like we would like to have now some different implementations and change something. We have to touch these modules and change things here. So, for example, we would like to export to a different module, and we have to change this code. So we are violating here some of the solid principles. But it is possible. But going further, so as I said, for now we are seeing that there is high coupling between the modules, but JPMS enabled something like services. So let's go through the services. What's services? So let's imagine we have our well-known API, which is like module.api, and it exports its package planet.api, which consists only this class with the interface. This API is used by our two modules, Earth and Mars, and what happens here? Here, we are now not using the requires or exports, but now we are going to provide to this interface. So we have this planet, it is our interface with method name. So just provide me this implementation of class, so Earth module, with this interface. And the same situation we are going to have for the Mars module when we are provides this interface with this implementation. And in the main module now, we are requiring only the API, so we are not binding ourselves with any specific implementation, and we are stating that we are going to use the planet interface itself. So now, as you see from the design perspective, it is much clearer than using the regular exports and requires. And how using this service look like in the code itself? So here we have our main module Elon. Here are the simple main implementation. And we all know the service loader, because this is not a new concept in the Java itself. So we are able now to load all binded implementations for the planet interface. So here is the class with the interface. So this is the interface, and we are loading all implementation. And if we will run this planet for each planet, just display me greetings, it will display in our situation the greetings from Earth and greetings from Mars. But in some cases, probably we just want to select the specific implementation. And also, when you saw the previous slide, here we have the direct implementation of selecting the specific implementation, and maybe we would like to hide it from our code because this is too low level and we would like to have it in different place. So we can introduce a well-known design pattern factory method, and we can just hide our implementations. In our case, it will be in the interface itself, and we will have like planets. And then we have just simple clean method for getting all the planets, and again, the output will be greetings from Earth and greetings from Mars. But sometimes we would like to have a specific selection on specific implementation. So here at the right side, we have our modules. So just to visual reminder, we have this provides with specific implementations. And here we have the API, so how this factory method is implemented. So new entry pop-up in the module of API, because we are going to introduce our factory method on the level of the API itself. So we are going to use planet class, and here in the interface, we are just implement iterable from the planet, and we are just hiding the service loader. So nothing fancy, nothing very complicated. But as I mentioned, in some cases, we don't want to have all implementations, but we would like to select the specific implementation. How we can achieve that? So imagine like we would like to have some annotation, and we would like to annotate like, for example, Earth is our local planet. So let's introduce some annotation local. It will be always set for true. And here, our module, which implements the interface planet, is annotated with the local itself. So how now we can use this for the selection? This is the final version, so we will have basically like two factory methods. One is which returns all the implementations. We already knew that. And here we have the local planets. But how the local planets factory method is implemented? This is simple creating a stream from the all implementations. Here is our service loader, which loads or binded implementations for our module. For the interface itself, we are creating the simple stream, and we are going to filter by some predicate is local planet. And here we are just mapping the specific implementation. The provider is the class which is inner class in the service loader. It is exposed, so it is used. And we are collecting this to list. And here, this is local planet is nothing fancy, because as I mentioned, this is a simple predicate, so function which just return true or false. And this local planet implementations, based on the implementation it is binded, just checking if this planet provider, the type, is annotated with our local annotation or not, and just checking if this type, the value of the annotation itself, is annotated with the value true. So our default value was true, so this will always be true. And here, for example, for the Earth implementation, this will be true. So nothing fancy, but this is basically the way how you are select the specific implementation. There is also the worst case scenario when you are not using the annotations, and the trivial implementation is just having like simple method with the name or some type, and you are just explicitly compare and check if this implementations returns a specific name like Earth, but this doesn't sound so cool. Let's now focus about the compile time dependencies. Imagine that we would like to introduce new module, Pluto, which was in the past the planet, but now it isn't. So basically it's very similar because Pluto implements the API and is used by our main module. But here, in our main module, we have like require static module Pluto. What does it mean, require static? It means that this implementation can not be present during the runtime. And there was a promise when I was going to talk about the module path, which was also introduced, that, hey, on the module path, we are now going to check everything what is needed to run our application. But here is something like I am able to say that, OK, let's compile this code, but maybe or may not exist some module during the runtime. And then we will have no class definition found error. And there was a promise when they said about the JPMS that we shouldn't have something like this, but it is still possible. And even if you put your jar file with the module on the module path and tries to run the application, you will still have no class definition found error because you have to explicitly state it that, hey, I'm going to add this module because this is the static module, and it has to be explicitly stated that now this application is going to use this. If it is not stated, the module will be not picked up, even if it's placed on the module path itself. Who thinks like transitive static is possible and who thinks it's not? Who thinks it's possible? Who thinks it's not? So I can tell you that this is possible, but does it make sense? Not really. It can be used for implementing the optional modules, but in fact the services which I just introduced is just the better thing for that. And it can be used for enabling some modularization of legacy code. But it has this advantage that we put the responsibility on the consumer itself to checking if something exists or not. So just implement simple try-catch, which is not very elegant in this case. Deep reflection. It was promised that now with JPMS we are going to have a strong encapsulation. So imagine that we extend our Earth module with the non-public class and not exported package. And what we are going to have if we will apply our well-known reflection. So we have like get declared method, set accessible on true, get system class loader. We are going to load this class, non-public class. And here we are getting the constructor itself, and we are trying to use the reflection, the well-known reflection, to get the information about and execute basically the methods from the non-public class and not exported package. And what we are going to have this. In JPMS, for the first one, we are going to receive inaccessible object exception. And for the not exported package, we are going to have illegal access exception. But there is a hack, maybe not hack, there is an implementation in the JPMS which allows us to override this concept. And there is a keyword open which allows us to open module for the reflection. And in what cases it can be useful? For example, you have some dependency injection frameworks or some other frameworks like test frameworks or Lombok or whatever, and they are trying to use some internal implementations, internal usage of internal components which shouldn't be exposed, so then we can write this. And we have various options, so we can open the whole module. It is like a bit a smell of code for me here, because while we are exposing our internal stuff, it's maybe shouldn't happen. Also, we are able to open only the specific packages, so this is better. And here is the one I don't like, because we are opening the specific packages, but again to the specific modules. So again, we are introducing the high coupling here. So it is not possible, what JPMS says and commercialize, that it's not possible to use reflection, but in fact, there are keywords in JPMS itself which allows this. And when JPMS was introduced, the other tools like Maven was not yet prepared, so we have to start with the creating basically our own make files in the bash files to the compile, packaging, and create runtime image. Fortunately, since 2017, things started to change, and Maven now basically supports the compiling, linking, and executing the JPMS modules. And the compiled sources of such modules looks basically as previously. So we have our classes compiled to Elon class, and module minus info is also compiled to the class. What is a cool thing about JPMS is like we can create our runtime image, which will contain only required modules from Java and from our modules, and this will reduce the size. But if you think this will reduce size significantly, for different person it can mean different things, this simple example is shrink to, who thinks, how many megabytes? How many? 40. It's 12, in fact. So to the 12 megabytes. And here, as you see, this is the runtime image for the Windows system, but when you are using the JDK for the Linux, it will generate the runtime image for the Linux version. And here, as you see, we have exactly the modules we are using. There is nothing more. Also for Java, it's only Java-based. And we can also check what modules exports and what module requires. And I already mentioned about the module path. So in the past, we have the class path hell, because the dependencies were kept in the class path file. It is like regular file, and we didn't keep the order of dependencies. So there can be collision when we have two different versions. And we have the module path, and they thought that now we are going to build like this tree structure. So we will upfront know every module which is required to run our application. And if this module or some modules are missing, we will just simply not run the application. But as you already saw, there are some required statics which still can produce the no class definition without error. So this module path can also have some issues. The another issue is that, as I mentioned about the name of the module has to be unique. You cannot have the two modules with the same name on the module path. It will just not work. And if you will have additional folder, for example, in the module path, and then you will hide your module with the same name, the JPMS just will randomly pick the first which it finds. Linking, it uses explicit dependencies from module. And as I mentioned, this is for the aggressive optimization because we upfront know what we are going to use. And we are not having the versioning of the modules. This annotation here, like we have at 10, this is only for human perception. So we know this is in version 10, but for the compiler, it is totally omitted, and we are not having the versioning. We have to use the Maven or Gradle to keep the specific dependency, to keep the version. And a bit comparison between the OSGI. So here we have the module versus package dependencies. So module dependency, we are depending on module no matter what is in this module. And package dependency, we are depend on the bundles itself, and we have the better decoupling. So these pictures show that since Java 9, we are working on modules. You already saw this, that we are providing the modules and we are exporting the packages, but we are importing the modules. So the other module, like Elon, it uses the classes from the exported package, but we have this in module minus info Java class, Java file. We have to state which module is required. So this is the static binding, like we are requiring the module, but from the module we export some packages, which is then export the classes. And in the OSGI, this was like basically bundles or packages, so we were exporting the packages and importing the packages. And exported packages are only visible to predefined friend modules, and it was necessary to split our JDK. And only one module may export a given package to the another module. So also the name of the packages has to be unique, not only the modules itself, but also the packages. So because this will lead to an error. And one of the main differences is difference between the services and services in the OSGI. So in the OSGI, we have this programmatically wiring. So we were able to dynamically during the runtime load or unload some plugins, for example, some bundles. And here we have this static binding. And we can emulate this. There is like service layers, and we have the different service loaders on a different layer. And we can emulate this, but this is in fact not a life cycle. This is somehow which behaves like dynamic loading, but in fact it's not. It is statically defined that this module minus info Java file, it's stated that only these modules can be used. And here we have this life cycle, and services can be dynamically loaded and unloaded. So we had all this great promise that JPMS will introduce the new cool feature, new flagship feature, and we will now have everything coolly working. It will introduce the strong encapsulation, and now our lives will be better. Finally, we have this cool feature. But then what happened? I've decided to run commercial project using JPMS. And this is basically the most important part of this presentation, because it will show you if I should use this in my next project, or just wait, or maybe it's not worth to spend time on it. So what happened on the commercial project? So here, this is the simulation of the part of the commercial project. Let's call it commercial project. So we have here the model module, which in fact implements our domain model. Here are tests for our domain model. And here's, for example, the simple implementation for the two persistent layers. So we have like repository in memory and repository Postgres. So we have like two implementation of our storage. And what were the issues? First issue, the module minus info Java file has to be located only once in the Maven module. So if so far so good, but if you would like to have some tests, for example, you think, hey, I will gonna to create in this Maven module additional JPMS module just for test, it will just not work. What's more, the module minus info Java file has to be placed in the main Java folder. If you are going to place it in the main test, as for example, when we are running test, and this is natural way and logical way to put the test in the folder with name test, it will just simply not compile, not work. Strange, but this is how it behaves. But this is not a problem, because if we are providing our implementation as a test itself, and it is a JPMS module, so in our test, we would like to test it as black box, in fact. So let's pretend we would like to have a real-life environment. So if on the runtime, on the production, it will be used as a JPMS module, then test it like a JPMS module. So we've created a separate module. And of course, it has to be now located in the Java main, not in Java test, as I mentioned. And if you would like to delete this module minus info file, then you will have basically like old Maven module project when no JPMS will be used. And when we are going to test it, we are going to use JUnit 5. And here we have example of how our model test module look like. So imagine we have some filtering scenarios here. Here we have this module minus info file, which describes that this is our test module for our domain, and we are going to use JUnit 5. First, you would like to probably, if you are using IntelliJ, enable your test in your IDE, because they will not work by default when you are using JPMS. So Maven compiler has had in the past source and target. Here are examples in Java 10. And since Java 9, there was introduced a new option, release, when you just stated release 10, which stated that now I'm going to build the stuff in the Java 10. However, the Maven compiler plugin is not yet updated, and I have to explicitly state that use the old switches for this. So this at least will allow me to run the test from my IDE, not every time run from the command line. Again, here is when we are going to use the open module. Because when you run the test written in the JUnit 5 on the module itself, from the different module, it seems that JUnit 5 using some reflections and other magical stuff, so you are going to receive errors. And the only way is to override this, is to open these modules for any kind of activity, so reflection activity, which the JUnit 5 framework would like to do. And also, as we are not allowed to use the main test folder in our Maven module anymore, we have to, in our POM, explicitly say that here we are going to use our new test source directory, which is source main Java. So this is the first issue you are going to encounter, and we know, we all know probably, if we would like to deploy something on production, it should have the proper testing. So this is the first issue with this. And here will be the trick. So let's get back to the basic, let's get back to the start of this presentation when I introduced the services. And here is basically a well-known implementation for service loader. And I would like to, for my interface repository read service, load all binded implementations. So this code will work or not. This is the regular main class, main method, regular class, and here I'm going just to display if there are some implementation. Will it work or not? Who thinks it will work? Okay, who thinks it will not work? Okay, so this will work. So this is because this is the regular implementation as I showed at the beginning, so this will work. However, check this out. If I'm going to do exactly the same, but the main method will become a test, and I'm performing exactly the same code, do you think it will work or not? Who thinks it will work? Who thinks it will not work? Yeah, so it will not work. I spent like evening because it seems like the runner for the JUnit 5 overrides somehow the JPMS, so you are unable to test in the JUnit 5 the services in JPMS. You are only allowed to test regular JPMS module when you use the export and requires. If you would like to test the services, JUnit 5 is not ready for that. Another problem, automatic module name. So in the past, we have this module, so no module, but the jar file is located in the class path. Then when module JPMS was introduced, we have this module path. And if something is not explicitly written as a JPMS module, so without this module minus info.java file, and you put it on the module path, it will become an automatic module. But as I said, the name has to be unique. So imagine we are going to have module A, and module A in the Maven will have the dependency PostgreSQL, and artifact ID is PostgreSQL, and this is some driver for the JDBC itself. And we have our module B, which could be our test module, for example. And we would like to use the org.test containers. Test containers is a library which allows us to create a Docker image with your real implementation of the Postgres. And here the artifact ID is also PostgreSQL. So what happens if we have situation when module B is going to use module A? And we have the same artifact ID. And the JPMS is using unique names. So we are going to have ambiguous module reference, PostgreSQL, in the definition of our test module here. And is it a thing we can do to fix this? So basically I thought, hey, this is probably the similar issue when I have some colliding dependencies, and we have the exclusion mechanism in Maven, so I will just exclude the PostgreSQL from the base module, and just this probably will use the module from the top module, so from the module B. Do you think it worked? Do you think it will not work? Yes. So basically, the only advantage is like this ambiguous thing warning just disappeared, but it will not work, and you will just receive the compilation error. So it not work. It's still ambiguous, and you have in the bunch of error messages, this is only a part of it when you are just having the information that basically doesn't know from which module I should use the implementation. And libraries and frameworks. One of the people from my team would like to use Lombok, so let's try Lombok in the JPMS. But unfortunately, there is no Lombok which works with JPMS yet. I noticed that there is Lombok Edge, which was not yet even pushed to the main Maven repository. So we were unable to use the Lombok. Groovy Spock, we would like to write the test in the first place in the Spock, because I like them better visually when I write the test. But unfortunately, and also we are using the Java 10, so basically Spock is not ported to Java 9 and Java 10. So I've noticed that I have to use the target source as Java 8, so no JPMS, so I was unable to use the Spock. Fortunately, we tried also, because we'd like to have some communication REST communication service, Spring. We were able, after some work, to encapsulate the Spring itself in the JPMS module, and it worked. But due to the fact that we were unable to use other libraries, we just had to delete our module -info file and use it all the way on the class path. Future issues. When you are compiling stuff with Java 10 and higher, you will notice like an illegal reflective access operation has occurred. For now, it works, but in future, this is going to be denied operation. So now they allow it to have it like a warning, but in future, all reflective actions on the module itself will be forbidden. So your software will stop working eventually. Take away from this session. So yes, we have this strong encapsulation, maybe not so strong because we have this opens keywords which allows to open through the reflection, our module, but it enables thinking about the modularity and what in fact should be exposed to the customer, the client, and what not. You can write your domain logic, which should be in fact implemented in the POJO. So we all know the correct definition of the POJO. This is not like a stupid, simple class with getters. This is the implementation using as less external frameworks, libraries as possible. So we have any Java code which is not contaminated by external frameworks and libraries, because it will not interfere with the JPMS system itself. About the testing, there are still issues with the testing, and for example, I strongly advise on testing, on TDD, on writing tests, and test your application, but this is limited due to the fact that some libraries not support the fully or at all the JPMS, and you are going to be able only to, as black box testing, test as in a limited scale. Word is not ready yet. So as you see, 2017, this was the official release of JPMS, but still people just didn't catch up with the implementations. A lot of implementations just simply are still in progress and it's still not work. So you can already design by modularity because you can think about this, you can use the Maven module itself, but I advise postpone any decision to using JPMS for the next months at least. Thank you very much. The examples are placed here. I will put them on the Twitter probably, so you can check the examples and you can help me improve by getting your feedback. If you have any questions, and we are out of the time, so you are welcome to approach me after this session and I will gladly answer any of your concerns. Thank you very much.